Good morning, Algebra. It's Thursday, April, I don't even know. It's on the whiteboard. You'll see it in a minute. I hope you're having a good day. I just want to tell you the window's open today, so if you hear the neighbor's German Shepherd barking, what have you, I would close it, but the cat's looking out the window, so she would be kind of mad if I did. Don't want to make the cat mad. Today we're starting something new, so I apologize in advance for the length of this video. It's going to be longer than usual because I'm explaining something you may have not done before. I posted a notes page and I posted a practice worksheet. Those are optional. You don't have to do them. I do have a 10-question Alex assignment that I assigned that I really would like you to do. It reviews inequalities in one variable and it reviews inequalities in two variables, which is what we're doing today. I'm super excited. Let's get started here. We'll go ahead and do our Pinterest post. Oh, there we go. It's April 9th. So like I said, we're starting something new. The notes and example will be in this video, and the 10-question assignment is on Alex, not Edulastic. I'm trying something new. April every year, April during quarantine. It has been so nice. It really has. Although it really hasn't stopped people from going out. People normally, people during quarantine. I'm sure you've all done it too, but he's going a little stir crazy. You know, I love Kermit. I wonder if Target misses me too. I really miss Target. Just want to wander the aisles. This one was cute. Do y'all think bugs are born knowing they can walk up walls? Or do they just accidentally do it one day and go, yo? Oh, that's super fun. Okay, so for your notes today, let's hop over to the examples. All right. So here we have graph the inequality. And I started off with examples that just have one variable in them. Our new unit has two variables. And we've graphed these on a number line before, but we've never graphed them on an XY coordinate grid. And so I want you to have an example of this. Now, what you would do here is you would go ahead and solve this inequality just like you normally would. Let me switch to pen. Okay. You want to get y by itself, so you would subtract 6 from both sides. And then you would have 2y is greater than or equal to negative 6. And then you divide both sides by 2. And you will have y is greater than or equal to negative 3. Okay. So then you got to look at these little graphs down here. Which one of these shows all the places where y is greater than or equal to negative 3. Well, you can eliminate these two. This one here, because that's at positive 3, and this one's positive 3. So looking at these two, which one indicate the area of the graph where y would be greater than or equal to negative 3? Well, clearly it's this one because all of the values greater than negative 3 are above it. Okay? Stop me if you have a question. Sorry, you can't do that. Here's another one. This one's got x, okay? We would go, again, solve for x by subtracting 1 from both sides. That gives me 1/2 x is less than 2. And then we would multiply both sides by 2. Multiply both sides by 2. And we would get x is less than 4. Okay, now because this is less than 4, it's not less than or equal to, we're going to be graphing this with a dotted line. On the XY grid, that's the open circle version of the number line. So we're looking for graphs that have dashed lines. So we can eliminate these two because they don't have a dashed line. Now, both of these show x at positive 4, but which one shows when x is less than positive 4? This is the winner right here. Winner, winner, chicken dinner. Because the values to the left of 4 are less than 4. Okay? So that's what it looks like when we are graphing just one variable. But what happens, how do we do this when we have two variables? That's what I'm excited to show you. Okay, so this little paper over here, this is the PDF that I linked on Google Classroom. And you can print that if you want. It's not exactly my stellar doodle notes, but it really gives you the idea when you're graphing inequalities. If you're graphing, if you have a dashed line, yeah, okay, let me start over again. If you have or equal to, you're going to use a solid line. If you have just greater than or less than, you're going to have a dashed line. Now, you guys are pretty sharp. So shading below, if it says less than or equal to, you're going to shade below the line. If it says greater than or equal to, you're going to shade above the line. And you'll probably be able to do that because you guys are all pretty perceptive. Most average math students have to find a test point to figure out where to shade. And you're going, what are you talking about, Ms. Williamson? What is the shading you speak of? Well, I'll show you in a second. If we were going to graph this inequality up here, okay, this is already in slope-intercept form, okay? So, and we know we're going to have a solid line because we have less than or equal to, okay? So we're going to graph it just like we would any inequality, any linear equation. Positive 5 is our y-intercept, and the slope is -2. So that would be down 2, right 1, down 2, right 1. Okay, and rather than try to draw this line, I'm going to use the line drawing tool because I stink at drawing lines. So you would have, I don't want the dashed line. How did I get the dashed line? No, I don't want that. Hang on a second, I'll figure it out. Okay, I'm back. The line drawing tool was hidden behind the record thing. I couldn't find it. Okay, so I managed to find one. It's a solid line and it has arrows on both ends. Okay, now it's a solid line, you'll remember, because this is an or equal to. If this had just been a less than, we would have used a dotted line. The question we have to ask ourselves now is, what half of the grid do we shade? There are a lot of values that make this inequality true. And we've got to figure out one side or the other will make it true. And what we normally do is we take a test point, and the most popular test point is 0, 0. It's the easiest to plug into the equation. So we would take a test point of 0, 0. And see if this makes this equation true. If it does, then that's the side we want to shade. If it doesn't, then we want to shade the other side. One side or the other is the right side. So if we solve this with replacing x and y with 0, because we're using the point 0, 0, we would have 0 is less than or equal to 5. Well, since 0 is less than or equal to 5, the side we shade is going to be this side. Now, graphing this has been quite a handful. But luckily, well, and unluckily, you're going to be doing your assignments for this section on Mcgraw-Hill. Let me tell you why. Edgelastic doesn't have the ability to have you solve an inequality and graph it. There's just no format for that. So what I did was I went through Mcgraw-Hill and I created a practice assignment and a quiz with the simplest problems they had. Okay, so let me show you what a Mcgraw-Hill problem might look like. Well, let's see. I'm going to, well, it's not going to work, is it? I'm going to have to change. Oh, let's just go. This is what a Mcgraw-Hill example would look like. All right, they give you the equation, and then you just have to pick the right graph. Okay, so if we were going to graph this one, we would have started at -5 on the y-axis. You can see all of the possible solutions start at -5 on the y-axis. Then they have a slope of +1. Well, they all have a slope of +1. So most of the work is done for you. Which one of these has the appropriate type of line and has the right half of the graph shaded? Okay, well, because this is an or equal to here, we can immediately eliminate both of these ones over here because these are dotted lines. This would be if it was just greater than and not or equal to. We have to decide which of these two are shaded in the appropriate place. Now, if you remember the graphic organizer I showed you at the beginning, it says that if you have a greater than, you shade above the line. Well, sometimes with these lines, it's hard to tell what above would be, but I think you guys are pretty savvy, and I think you're realizing that this is probably the right one. We can use our test point of 0, 0, though, to make sure. If 0, 0 works in here, this is the correct choice. So let's try 0, 0. 0 is greater than or equal to 0 minus 5. Is 0 greater than or equal to negative 5? It sure is. So this is the winner right here. This is what the Mcgraw-Hill problems will look like. I don't think you're going to find them very difficult. Let's look at another one. Here we would graph this. We would have put our y-intercept at positive 4. All of the graphs have the y-intercept at positive 4. And we would have had a slope of 2. All the graphs have a slope of 2. Which 2 can we eliminate? Well, we have an or equal to. So we can eliminate this one, and we can eliminate this one. Okay? Which of these two is shaded correctly? Using the graphic organizer, it says a less than means you shade below the line. Well, this one appears to have the shading below the line. It's a judgment call, but yeah, it's below the line. So I'm thinking this one's the right one. Again, if we use a test point of 0, 0, we would do 0 is less than or equal to 2 times 0 plus 4. And in fact, 0 is less than or equal to 4. So this is our winner here, this one, and you just pick that one. So all the problems that I'm going to be asking you to solve in the next couple of days look like this, where they give you the equation, they give you 4 graphs, and they ask you to solve them. Now with this one's not in slope-intercept form, so this adds a little bit more of a challenge for us. We have to put this in slope-intercept form before we can decide how to graph it, or even select the correct graph. So if we start, I'll rewrite the problem over here. Less than or equal to 12. We want to get y by itself on this side, so let's subtract 7x from both sides. And that gives us negative 3y is less than or equal to negative 7x plus 12, because that was a positive 12. And then we have to divide everything by negative 3. Now here's the thing. Remember that little rule about flipping the sign? That still holds even on these. So we're going to have to flip our sign here. Y is greater than or equal to negative over negative makes a positive. We have a slope of 7/3 x, and positive 12 divided by negative 3 is negative 4. So our starting point on the y-axis is negative 4. It's our y-intercept. Our slope is positive 7/3. So we go up 7, 1, 2, 3, 4, 5, 6, 7. And right 3, 1, 2, 3. All right, let me try to use that line drawer again. See if I can do it. Line drawer, arrows on both ends. I want a solid line, right? Yep, I need a solid line. So, it's a little off. I can fix it. See, aren't you glad I'm not asking you to actually graph these things? You just have to pick the right graph. Because graphing is kind of tricky. Yeah, that looks pretty good. Yeah, I like that. So now you just have to decide which side to shade. Because it's greater than, we know that we need to shade, sorry, my cat's going crazy. We need to shade above the line. So it's kind of leaning toward vertical, but you can kind of tell that this is the above the line. And so let's try that test point of 0, 0 and see what that does for us. Oops, I need a pen. If we put 0, 0 in here, we would have 0 is greater than or equal to 7/3 times 0 is going to give us 0 minus 4. Is 0 greater than or equal to negative 4? Heck yes, it is. So this is the side we want to shade. That's terrible. You'd want to shade the left side. Yeah. Don't judge. All right, my last